Welcome again. So this problem was in JEST 2018. Okay, an electromagnetic wave of wavelength lambda is incident normally on a dielectric slab of thickness T. If K is the dielectric constant of the slab, the change in phase of the emergent wave compared with the case of propagation in the absence of the dielectric slab is. So हमें बस ये find करना है what is the change in the phase. Okay. So if we briefly review what happens to a wave when it propagates from a rarer medium to a denser medium. So three things happen. So first of all, no change in frequency occurs. Okay, जब भी wave travel करेगी from a rarer medium to a denser medium, no change in frequency occurs because the frequency depends on the source. Okay, wave will slow down obviously, and the wavelength decreases. And what happens to a wave if it travels from a denser medium to a rarer medium? Again, no change in frequency occurs. Wave speeds up and the wavelength increases. Okay. And one more thing that we have to note is that the refractivity index, which is equals to speed of light in vacuum upon the speed of light in a medium, can be written in terms of the relative permittivity and the relative permeability as under root of ER multiplied by mu r. Okay, and mu r can be taken as 1 because most optical materials and dielectrics are slightly magnetic. So mu r to a good approximation can be taken equal to 1. So mu r is equal to under root of ER, and in this problem it can be written as under root of K, where K is the dielectric constant. Okay. So in this problem what we have a wave. Okay, so this is our wave which is traveling through a dielectric slab of thickness T. Okay, and if we compare it with a wave which is traveling in a vacuum, तो हम ये देखेंगे कि जो wave dielectric से पास हो रही है उसकी speed कम हो जाएगी, and because of that there will be a phase shift obviously. Okay, so वो phase shift हमको find करना है. तो पहले हम देखेंगे what is the time lag, कितना difference आ रहा है time में. Okay, क्योंकि ये वाली wave है ये slow हो जा रही है. Okay, compared to this wave, so there will be a time lag obviously, and that time lag can be calculated as the time. Okay, that is the distance upon speed in this for this wave and distance upon the speed for this wave. Okay, so t by v minus t by c is the time lag. Okay, and from the because we know v equals to c by n, which equals to c by under root of k, and if we substitute we can find that time lag equals to t by c times under root of k minus 1, and we can also find what is the path length difference, and path length difference is simply speed times the time lag. Okay, and that can be written as t times under root of k minus 1. Clear? And अगर हमको path length difference पता चल गया ना, we can easily find what is the phase shift. Phase shift is simply given by 2 pi by lambda times the path difference. Okay, if we substitute the values, we'll get simple that phase difference equals to 2 pi by lambda t under root k minus 1, and so this is the fourth option, 2 pi by lambda t under root k minus 1. So this will be our change in phase.